Hey class, in today's lesson we're going to talk about solving trigonometric equations, which is found in section 5.3 part 1. Our objective is to use standard algebraic techniques to solve trigonometric equations. So in our first example, we are asked to solve a trigonometric equation. So we are asked to solve 2 times the sine of x minus 1 equal to 0. So essentially, it's literally just an equation that just happens to have trig functions in it. So the same applies as we are typically trying to solve for any equation, is that we would just want to get the x value by itself or the unknown value by itself. So we're going to add 1 to both sides. And we're going to get 2 times the sine of x equal to 1. Then I would divide by 2 on both sides. And so then I'm going to get that sine of x equals 1/2. So then you just have to ask yourself, for what angle would sine of x equal 1/2? Well, first of all, sine is positive. If we think about all students take calculus, sine is only positive in the first and second quadrants. And if you remember, I've given you a basic fact that sine of 30 always equals 1/2. So we have to think about the fact that there is a 30-degree angle in this quadrant, but in this quadrant, the reference angle that would have a 30-degree angle is actually 150 degrees. And we want to also think about those in terms of radians. So not only is it x equals 30 degrees and 150 degrees, we also need to think about it in terms of radians. Maybe I shouldn't draw it like that. But in terms of radians, that would be pi over 6 and 5 pi over 6. Okay? So again, we're solving for an unknown. We decide what quadrants, based off of positive and negatives, what quadrants they fall in. And then after that, we determine, based off of its reference angles, what they kind of fall for. Okay, so then in example 2, we're going to find all solutions in the interval from 0 to 2 pi. And that's essentially what we did on the last one. And it just wasn't stated, but that's essentially what we did, because you want to find all solutions, not just one possible solution. So here what I want is I want all my signs on the same side, and then I want all my numbers on the other side. So essentially I want to add sine x on both sides, and I want to subtract the square root of 2. Okay, so that leaves me with sine x plus sine x is 2 sine x, because I have 1 sine x plus 1 sine x equal to 2 sine x, equals negative square root of 2. Okay, if I divide by 2, that will give me that sine of x is equal to negative square root of 2 over 2. Now that should be recognizable as a 45-degree angle, but we just have to figure out where it is. So again, with all students taking calculus, sine is negative in the third and fourth quadrant. And we already said that square root of 2 over 2 as a sine references a 45-degree angle. So a 45-degree angle in this quadrant would be 225 degrees. And a 45-degree angle in quadrant 4 is 315 degrees. And as radians, that would give you in the third quadrant, that would be a 5 pi over 4. And over here, that would be 7 pi over 4. So any of these 4, however it's asked of you, if you want degrees or if you want radians, those are your solutions. Okay, let's look at the next problem. Okay, so in example 3, we're asked to solve the equation again, but this time it's saying from 0 to pi. So we're not going to do a full 360 degrees. We're just going to do technically 180 degrees. So just the upper quadrant, so out of first or second quadrant. Okay, so if we have 3 tangent squared x minus 1 equal to 0, and we're solving for x, the first thing we want to do is add 1. So then we have 3 tangent squared x equals 1. Then if we divide by 3, we have tangent squared x equal to 1/3. We only technically want tangent x, so we're going to take the square root of both sides, and we're going to be left with that tangent x equals plus or minus the square root of 1/3. But what makes more sense to us, we haven't really dealt with the square root of 1/3. We've dealt with really more so, if I take the square root of 1 over the square root of 3, that really gives me plus or minus 1 over the square root of 3. So let's think about that. If I'm talking about tangent, and you have to understand that with tangent, the positive of that tangent, if I'm only talking about from, I can't choose from the third or fourth quadrant, the positive tangent will fall in that quadrant and the negative tangent will fall in that quadrant, right? We know that tangent is opposite over adjacent. So my opposite of my angle theta will be 1, and my adjacent is the square root of 3. Therefore, this is because I know if theta is opposite from a 1, then really what we're talking about is a 30-degree angle. So then x is equal to 30. And in the other one, this then would be as a reference angle. If this reference angle is 30, that means that in quadrant 2 right here, that theta is 150 degrees. And again, in radians, that would represent pi over 6 and 5 pi over 6. And it's up to you which one you decide to use if you want degrees or radians. All right, let's look at our last example. So again, we want to solve the equation in the interval from 0 to pi. So let's take a look at that. On this one, we have cotangent x cosine squared x equal to -2 cotangent x. My recommendation first is to move everything to the same side. So we're going to subtract 2 cotangent x on both sides. We're going to be left with cotangent x cosine squared x minus 2 cotangent x equal to 0. Okay, from there I should be able to factor. And what I can factor out is a cotangent x. If I factor out a cotangent x, I'm left with cosine squared x and then minus 2. Okay, so that's just like factoring. So essentially I can take this one and set it equal to 0 and that one and set it equal to 0. So if I have cotangent x and I set that equal to 0, well, let's do the math on that. If cotangent is 0, that means that if we think about cotangent and tangent share in their property setup, except tangent is opposite over adjacent, so cotangent is adjacent over opposite. So where is the adjacent over opposite equal to 0? Well, adjacent over opposite that is equal to 0 is at pi over 2, because that ordered pair is 0, 1. So if I put 1 over 0, that gives me 0. So that one, that solution then would be x equals 90 degrees or pi over 2. So that's my first solution. And again, we're talking about just from 0 to pi rather than 0 to 2 pi. Okay, if I do this next one where cosine squared x minus 2 equals 0, what I would do is I would add 2 to both sides, and I'd have cosine squared x equals 2. I would have to take the square root of both sides just to get cosine of x, and so I have cosine of x equal to plus or minus the square root of 2. The thing is, with that one though, it is not possible simply because the range of cosine only falls, the range of cosine only falls between -1 and 1, and square root of 2 is greater than 1, so it falls outside of the range. So there is no solution for this second half of the answer. So my only solution that I was able to find is x equals 90 degrees or pi over 2. We'll talk more about that second situation in coming lessons, but for the most part for now, just understand that due to the range of cosine, the math that was given to us is outside of our range, so we won't be able to do anything with it. All right, guys, if you have any questions, again, please be sure to come see me for tutoring.